We're beginning our discussion looking at the Basic Education Department, Republic of South Africa. The Senior Certificate Examinations, National Senior Certificate Examinations, with a specific focus on Mathematics Paper 2, May, June 2023. Marks 150, time 3 hours. Okay, so I'll be focusing today on a wide range of questions. Because of time, I'm going to do critical questions. And then I'm going to return to other questions. I'm going to start by doing, for example, the question 3 and the rest of the other questions after. And then if time allows, I'm going to go back to questions 1 and 2. Because questions 1 and 2 require us to use calculators. So yeah, I'm going to train you on how to use calculators to perform certain calculations of coefficients and the averages, like your mean, your mode, and so on. You can just need to use your calculator settings on your Casio calculator. I'm going to train you on that. But now we are looking at question 3 in the diagram. The equation of line AF is given. So you have line AF. Right, here is A. And obviously we have F here. And the equation of the line is minus x minus 11. There it is. B is the point on the x-axis. Here is B. Right. Is the point on the x-axis is the midpoint of the straight line joining A and C. So B becomes the midpoint of the straight line joining A and C. The angles of inclination of AF and AC are alpha and 63.43 degrees respectively. AF cuts the x-axis at E, right? So we have that AF cuts the x-axis at the point E. This is a point such that D is parallel to AC. D is parallel to AC. Okay, now calculate the following, like the value of T. Okay, so we need to just find the value of T. Where is T? T is here. How do we find the value of T? Okay, so there are a couple of ways to do that, but the easiest way is to consider the any equation of the line that actually is such that A lies on that line. So we can see A lies on the line here, AF, but it also lies on the line AC. So yeah, the easiest one is AF. The equation is already known, so we're just going to use that one. What is the equation? It's minus x minus 11. So we're going to start by writing our y is actually minus x minus 11. And it is actually at the point A with the coordinates minus 1t with xy. xy. Y is t is, okay, so we put the y here, which is t. Then the x is minus 1. So you have minus 1 minus 11. What is the answer to this? Right, so if you multiply negative by negative, it's plus, so that is 1 minus 11, and that is minus 10. So, right, what is the value of t? Clearly, t is actually minus 10, and we are done there. Okay, next, we want to find the size of the angle alpha. What is the size of alpha? Right, so alpha is actually this one here, and we can see the angle, the equation of the line. That is making the angle alpha as an angle of inclination minus actually x minus 11. So you start as follows and say you have that y is minus x minus 11. And then you have the tangent of alpha, which is the gradient of the line. What is the gradient of the line? AF. Okay, that is the formula we're going to use. So that we have the tangent of alpha. The gradient is minus 1, like this. So now if it is minus 1 like that, we need to get what we call the reference angle. So what is the reference angle? The reference angle is going to be arctan of +1. Okay, so you consider a +1 and not the minus. And if you use that one, you get actually 45 degrees over there. So if the angle, the reference angle is 45 degrees, you look very carefully and understand that this angle cannot be 45 degrees. This angle is actually an obtuse angle, more than 90 degrees, but smaller than 180 degrees. So you then say alpha. You then need to say alpha is 180 degrees minus 45 degrees. What is 180 minus 45 degrees? Is 135 degrees. So which means that we have that alpha here is actually equal to 135 degrees, and this one is 63,43 degrees. Next question. The gradient of AC to the nearest whole number. So the gradient of AC to the nearest whole number, obviously we already know the angle of inclination. So we know we're going to use, there are two formulas for the gradient. So one formula for the gradient that we're going to use is that the gradient of AC is basically equal to the tangent of the angle of inclination. Normally we use the angle theta, and this means that the gradient of AC is the tangent of 63,43 degrees. And therefore, what is this one? It is actually equal to 2. And therefore, the gradient of the line AC equals 2. Okay, determine the equation of AC in the form y equals mx plus k, the equation of AC. Right, so if you want to find the equation of the AC, you already know a couple of things. You already know the gradient of the line, right? And we have already said the gradient of the line AC is 2 approximately. Moreover, we know that t itself is equal to -10. We've just found it. So we can easily be able to find the equation of the line. So we need just a point on the line and the gradient of on the line. So, or the gradient of the line. And so at this point, we know that the gradient, we want to find the equation of AC, and therefore we know that the gradient of AC is actually equal to 2. Okay, and therefore we know also that there is a point A with the coordinates -1 together with -10. And what is this? This is y minus y1 equals m into x minus x1. So which means you have y minus, what is y1? It's -10 into the x is 2, x minus x1 is -1. So which means that you have the following. What do you have? This implies that y is equal to, if you look at this is x, negative by negative is plus, 2 by x is 2x plus 2. Okay, this is negative by negative, which is a +10. You move it across, it becomes -10. And therefore, what is the equation? The equation is actually 2x minus 8. And that is the equation of the line AC in the form y equals mx plus k. Next question. The coordinates of the point C. The coordinates of the point C. Let's identify the point C. Right, so here is the point C, and we want to find the coordinates of the point C. But we know that B is the midpoint. Right, if you know that B is the midpoint, you can be able to find one of the values. Moreover, we already know the equation of the line as well. What is the equation of the line? But now, if the equation of the line is y equals 2x minus 8, you need to find the x-intercept of this, because B is the x-intercept. So at the x-intercept, you already know that y is 0, you just need to get x. So to find the coordinates of the point C there, we use a couple of things. What do we use? It is easier, much easier to just to find x at B, the x-intercept. That's what we're going to do first. The equation of AC you already know is 2x minus 8, and we find the x-intercept. So this is how we proceed about it. So we say y is equal to 2x minus 8. And then we're going to find the x-intercept. How do we find the x-intercept? You let y be equal to 0. If y is 0, you have 0 equals 2x minus 8. And this means 2x is equal to 8. Divide by 2, both left and right, dividing 8 by 2, it means we're getting x equals 4. And this basically is x at the value b. It's x at the point b, the x-intercept we actually are looking for. Okay, if this is x at b, that we just got, so we come here and we put x at b is 4. So now we can get the coordinates of the point C. The coordinates of the point C now, C is an end point. So we can put here x, c, y sub c. Okay, x subscript c, y subscript c. And then now we already have the midpoint. So we can use the midpoint formula. What is the midpoint formula? The midpoint formula says you take the x. So there is xa here, and then there is ya here. So you're going to take xa plus xc, you divide by 2, it is equal to 4. So what does the midpoint formula say? You take the midpoint. What is the midpoint? xa plus xc over 2. Right, so that is what you're going to write here. So you're going to write the following. You're going to write xa plus xc over 2. ya plus yc over 2. And this is 4 and 0. Like this, which is the midpoint, because the midpoint is actually having the coordinates 4 and 0. Right, if this is the case, what is the implication? What is x at A? Right, so we come to look at the point A, and we come to look at the point C. X at A is -1, at C is just x sub C. So we have x at A, which is -1, and then we have x at C, which is just x at C. We divide by 2, and this is equal to 4. Right, and we continue also, and then we have y at A. What is y at A? Right, we got it's t at A. Okay, so that one is -10. Is -10 plus y at C. You divide by 2 because it's the midpoint, and this equals actually 0. And what is the implication? Right, so I'm going to divide here a little bit to create a bit more space. Here. So, okay, when we get to this point, what is 2 times 4? 2 times 4 is 8. So that we have x at C. 2 times 4 is 8. And then we have 8 plus 1, which is what? Which is 9. So it gives us x equals 9. And then also we look at the y, 2 times 0. 2 times 0, we cross multiply. 2 times 0 is 0. Y equals 10. So you have y sub c equals 10. And then now we have this. What are then the coordinates of the point C? Right, so the point C therefore has the coordinates 9 together with 10 as an ordered pair. 9 together with 10. Right, the next thing we're going to do is to find the size of FED. The size of FED. The size of FED. Okay, so the size of FED. The size of FED. Okay, so obviously we can see exactly what is happening there. So we have FED, we're interested in finding the size of this angle there. So obviously there are a couple of things that we need to realize. But first, this one is 135 degrees, so that this one here is 45 degrees. It remains to just find this angle over here. Right, so we want to find this little bit here. Right, if you find this little bit here, you can see that if this is parallel to this, it is equal to this little bit over there. Okay, these are parallel, and therefore we are able to find the answer. What is the answer? So the answer is that this angle here is going to be, this one is angles in x in mathematics. This angle equals this angle. So this is 63,43 degrees. And these are vertically opposite angles. Right. So we have, therefore, how do we write that one down? So we're going to write that ABE is 63,43 degrees. We're going to write and say angle ABE, right, angle ABE is actually the same as 63,43 degrees. Why? Because these are vertically opposite angles. Next, if these are vertically opposite angles, what do we then say? Then we go on to say the following. We can call this one E1, we can call this one E2. Right, we need to find E2, so E1, E2. We can see clearly that angle E2 is equal to 63,43 degrees. 43 degrees. Why? Because the angles in F, they're called corresponding angles. Why corresponding angles? Because you have the parallel lines. What are the parallel lines? The parallel lines are actually as stated in the question. What are they? They are DE parallel to AC, DE parallel to AC. So they are DE parallel to AC. Right, what is the next thing? So now we have already found that this one is 45 degrees, because why is it 45 degrees? It is 45 degrees because 45 plus 135 is like 180, and this is a straight line. But the angle E2 is equal to this angle because in mathematics, if you have angles, lines like this, okay, you know that if this is parallel to this, an angle here is equal to an angle here. These are called corresponding angles. And therefore, this angle here is going to be the angle there. And this one is therefore equal to 63,43 degrees, okay? If this is 63,43 degrees, we come and realize therefore, that angle E1 plus E2 is what the examiner wants. And hence, now we then say FED. Right, so therefore, we say FED is actually the same as angle E1 plus angle E2. What is angle E1? We saw that it is 45 degrees. What is angle E2? It is 63,43 degrees. What is the summation of this? Is actually what is 43 plus 45 plus 63,43 degrees? Okay, right. The sum is obvious, but what is the summation? Right, the summation is 108, 108, 43 degrees. And this is the angle the examiner wants. 108,43 degrees is the angle FED. Next question. Next, examiner is saying G is a point such that EAGC in that order is a parallelogram. Right, let's look at that question. G is a point such that EAGC in that order is a parallelogram. Determine the equation of a circle centered at the point G and passing through the point B. Write your answer in that form. So, right, so we have 3.4. We have 3.4. Right, so what is the next thing to be done at this point? So there's a point G such that EAGC, let's look at that, EAGC. So you're going to look at E, A, then G, then C. E, A, G, then C. Okay. In that order. In that order. If you look at the fact that then you have E, A, G, C. Right. Let's look at that carefully. E, A, G, C. Right. So if you look at E, A, then there's G, then there's C in that order. Okay. So you could have the following. Right, if it's E, A, G, C, so the G is a point somewhere there. Okay, so that you have E, A, then there's G, and there's C. So you have something like this. Something like so. Something like this. Okay, you have something of that sort, but it's a parallelogram so that you have the opposite sides equal and parallel to each other. Okay, and this is the sort of shape you're getting. Okay, now I want us to analyze this carefully. If G is a point such that EAGC in that order is a parallelogram, determine the equation of a circle centered at G and passing through the point B. It's a circle that is going to be centered at A, but that is passing through the point B. Okay, the center is G, but the circle passes through the point B. So we need to find the coordinates of the of G. The coordinates of G. If this is a parallelogram, there are a couple of things that we actually can do. We can find the coordinates of A to be able to find the coordinates of G, because if this is a parallelogram, the diagonals bisect each other. So in a parallelogram, the diagonals bisect each other. Here is a parallelogram, and if you have a diagonal there and another diagonal here, this equals this and this equals this. So these are the properties of a parallelogram. And now it means if you can find the coordinates of E, which is very easy because the equation of the line that passes through E is known. The equation is minus x minus 11. We can find the coordinates of E. If you find the coordinates of E, then we have the coordinates of B, and then the coordinates of G will be obvious. And then if the coordinates of G are obvious, then we can be able to say the circle has a center G and passes through the point B. So you have a circle like so. We have a circle like so. But now, if we know G, then we can just find the radius of that circle. The radius of the circle, and then we're done. So let's do this. What do we do first? Let's find the coordinates of E, because then if you find the coordinates of E, B is the midpoint. Why is B the midpoint? Because this is a diagonal and that's a diagonal of a parallelogram, and therefore they bisect each other. Coordinates of the point E, the equation is y equals minus x minus 11. So we're going to use that. So if you look at the figure, you have y, which is minus x minus 11, and you're interested in finding the x-intercept. So to find the x-intercept, you let y be equal to 0. In this equation, 0 is minus x minus 11. And that means x is minus 11. And that means the coordinates of the point E will be x equal to minus 11 and y is 0. So which means therefore at this point we have x equal to minus 11 and y is 0. These are coordinates. B is the midpoint. Using the midpoint formula, we can easily be in a position to determine that. We can easily be in a position to determine that. So which means that we're going to draw the line to find the coordinates of G. We're going to draw the line E coordinates minus 11, 0, B 4, 0, G is what we want. So yeah, I'm going to draw a small line like so. E has the coordinates minus 11, 0. B has the coordinates 4, 0. Then you have G, the coordinates xg, yg. So we can, okay, this is like midpoint thing. Okay, so we don't know the coordinates of G, so we can find them. So which means that we're going to use the midpoint formula. What is the midpoint formula? It's going to be xe plus xg out of 2. Then it's going to be ye plus y sub g out of 2. And this is the midpoint. What is the midpoint? It's the point B, coordinates 4, 0. Xe is minus 11. Xg is x sub g out of 2. Okay, it is equal to 4. Y at E is 0. Y at G out of 2 equals 0. Okay, so what is x sub G? So this is 2 by 4, which is exactly 8. 8 plus 11 is 19. And what is y sub G? Y sub G is also 0. Okay, this is capable of giving us the coordinates of the point G. So the coordinates of the point G will therefore become x first, 19, and y 0. Okay, this will be the coordinates of the point G. And then if that is true, then we would be interested in finding the equation of that circle. So 19 and 0. So which means the coordinates of the point G are 19 together with 0. And so what we're then getting at this point is that we know the coordinates of G. What is the distance? If the y coordinates are the same, it means obviously we can easily get the distance. What is the distance between 19 and 4? Okay, it's 19 minus 4. What is 19 minus 4? It is 15. So the distance from here right to there is actually 19 minus 4, which is 15 units. That gives us the radius of the circle centered at the point G. And hence it means we have the following. That means that the circle centered at G, so you have G as the center with the coordinates 19 and 0, and this is the center. So which means you have x minus p all squared, y minus q all squared equals the radius squared. We have seen that the radius of that circle is 15 units. And therefore, we have the center, which is x minus 19 all squared plus y minus 0 all squared. The radius is 15 all squared. And this is x minus 19 all squared plus y squared equals 15 squared. So that is the answer. But now you can go to your calculator and perform squaring. Okay, if you got your calculator and you perform squaring, That will mean 15 squared is 225. 15 squared is what? Is 225. And therefore, it means that we have the equation of the circle the examiner wants in 3.4. Because if G is a point such that EAGC in that order is a parallelogram, the examiner said determine the equation of a circle centered at G, and the equation of the circle is this one, is x minus 19 all squared plus y squared equals 225. Next question. Question 4 is about the circles that appeared in this year's June exam. They expect the circles to feature in this year's November exam in a few days. Right, we just have a few days left. So in the diagram, the equation of a circle centered at N with the coordinates minus 12, 5 is this one. The equation of a circle centered at M is this one. PS and PR are tangents. PS and PR are tangents to the circle at M, at S and R respectively. PR is parallel to the x-axis. PR is parallel to the x-axis. K has the coordinates minus 17 minus 5. Is a point on PS. The straight line joining N and M cuts the smaller circle at T. The straight line joining N and M cuts the smaller circle at N and at T, and it cuts the larger circle at S. Write down the coordinates of the point M. We want just the coordinates of the point M here. What are the coordinates of that point? And the marks are only 2. The marks are only 2. This is what we can do. The equation of the circle centered at M is this one, x plus 6. So the equation here has x plus 6 squared, y plus 3 squared is equal to 25. And therefore the coordinates are minus 6, minus 3. You just put the negatives there. Okay, because you have pluses over there. All right, calculate the length of the radius of the smaller circle. You have the smaller circle, this one. What is the radius? But the circle center N, the circle centered at N has the equation this one, which is x squared plus y squared plus 24x. Right, we have x squared plus y squared plus 24x minus 10y plus 153 minus 10y plus 153, and this equals 0. Minus 10y plus 153 equals 0. So what is this? This is exactly x squared plus 24x. Then you add half the coefficient of 24 all squared plus y squared minus 10y plus half the coefficient of minus 10 squared. And this is the same as 153. Okay, half the coefficient of 24 is 12. If you square that, it becomes 144, which is added to the other side. You take half of minus 10, it's minus 5. You square, it's 25. The equation, therefore, becomes x plus. Half of 24 is only 12. And you square that. In this is y minus 5. You square that. And this is Okay, look at the fact that the 153 was positive and therefore it's going to become negative. It's going to become a negative 153. Because positive, it became now negative. Okay. And this is separate. And then if you have minus 153 now plus 144 plus 25, the answer is 16. What is the radius that is required? The length of the radius, therefore, is r squared equals 16. And therefore, you take the square root of that, which means r is the square root of 16. And the square root of 16 is 4 units. And therefore, this means that the radius of the circle is 4 units of the smaller circle. The length of TS is next. In view of that, if the radius now, you need to find the length of TS. What are the coordinates? And now this one of center M has its own radius. The radius of this one. Okay, the equation is clear. It's this one with 25 and 25 is 5 squared. If 25 is the same as 5 squared, it means the radius is 5 units. And therefore, we have seen that this one is actually having a radius of 4 units. We just need to find the length of TS. How do we find the length of TS? To find the length of TS, we proceed as follows. We just simply need to find a couple of things. We need to find the length of NM. N has coordinates minus 12 and 5. N has coordinates minus 12 and 5. And then M has the coordinates minus 6 and minus 3. M has the coordinates minus 6 and minus 3. So that now you can find the length. What is the length? NM. Okay, in view of using the distance formula, the length formula, we know that it is x2 minus x1 all squared, y2 minus y1 all squared, and this equals. Okay, we are moving from the point N to the point M, and hence NM, x1, y1, x2, y2, x2 minus 6, x2 minus 6, x1 minus 12 squared. Y2 is minus 3. Y1 is minus 5 squared. So that now in the end, if you do this, it becomes 10 units. It becomes exactly 10 units. So you have the line like this. So if you have the line here, NM, the rest of this length here is 10 units. If the rest of this length is 10 units, so it means that it is 5 plus 1 plus 4. Right, so yeah, NM. So I can write it here. Okay, you have N here. You have M there. You have T here. You have S there. You have 5 there. Okay, 4. It's 4 up. So this one is a 4. This is TS. But this is a 5. So the length the examiner wants is the length of TS from T to S. So which means that from this here, you know that NT can start like that. NT, you add everything, NT plus TS. NT plus TS plus SM, which is 10. What is NT? Right, NT is 4 plus TS. SM is 5. And this is 10. So what is TS? TS is therefore 10 minus 9. What is 10 minus 9? 1 unit. 1 unit. So TS is 1 unit. So they said find the length of TS. It's only 1 unit. Okay. Next question, determine the equation of the tangent PR. The tangent PR. Yes, P and S are, we want the equation of the tangent PR. So it's obvious this. How do you find the equation of the tangent PR? Right, so you can easily find the coordinates of the point R. What are the coordinates of the point R? You already know the coordinates of M. The coordinates of M are -6 together with -3. Okay, and that gives you an X. And the X here is -6. And the Y is, okay, it's -3 here. Y is -3 there, but the radius from here to there is 5 units. Okay, going down 5 units from here is, if you go down 5 units, is you have minus, so it's 5 here. So this one is going to be -8. So the first thing you write is that R has the coordinates -6, -8. R has the coordinates -6, -8. And what is then the equation of the tangent PR? The equation of the tangent PR, it is a tangent that is parallel to the x-axis. It is parallel to the x-axis because it's certainly perpendicular to the radius of the bigger circle. So, which means we have PR. What is the equation of the tangent PR? So the equation of the tangent is y equals -8. Then the equation of the tangent PS. So this one, PR, is the equation y equals -8. Why? It cuts through y equals -8 and y equals -8 at this point, and this is parallel to the x-axis. Okay, think about it. The next thing is to find as well the next question. The equation of the tangent PS. The equation of the tangent PS. Okay, obviously PS passes through the point K. So if it passes through the point K, we can easily be able to determine that, as long as we can be able to find a couple of things, like we can be able to find the gradient of the tangent. So, which means that the equation of the tangent PS in the form that This one. Okay. Let's find that one in 4 points. Right, so to find that one, we need to find the gradient first. The gradient of PS. But first we can easily find the gradient of NM. The gradient of NM. Okay, N has the coordinates minus 12, 5 in these. So we'll find the gradient N has the coordinates minus 12 together with 5. This one, M, is the coordinates minus 6 minus 3. So you can find the gradient. So you have y2 minus y1, x2 minus x1. x1, y1, x2, y2. What is y2? It's minus 6. What is y1? No. y2 is minus 3. What is y1? It's 5. x2 is minus 6. What is x1? Is minus 12. So this is minus 8 over 6. So minus 8 over 6 becomes minus 4 over 3. So now you're going to deal with the gradient of the in mathematics, the gradient of the now this one here is like radii, because if you want to find the gradient of this, it's like a radius here, and therefore it's always perpendicular to a tangent. So the gradient of the tangent here, because it's perpendicular, so the gradient of the tangent is going to become, you reciprocate it, so it becomes 3 over 4, and if it's minus here, then it becomes a plus. Okay, so yeah, the gradient of the tangent with this is one is like a radius. Like a radius. But the gradient of the tangent becomes 3 out of 4, then you change the sign. The reason for that is that the gradient of the gradient 1 times gradient 2 is equal to minus 1 wherever you have that a tangent is perpendicular to a radius. Like this. So that in the end, what you're getting here, you have y is equal to, you have y minus y1 is equal to m into x minus x1. Y minus. Okay. So obviously we agree that the equation of the tangent PS passes through the point K with coordinates minus 17 minus 5. With K with coordinates minus 17 minus 5. Minus 17 minus 5. Which is x1, y1. Which means we have y1, which is minus 5. The gradient of the tangent is 3/4. X minus x1, which is exactly minus 17. So y is equal to, so which is 3 out of 4 x plus 31 out of 4. 3 out of 4x plus 31 out of 4. So we have found the equation exactly in the required form, y equals mx plus c. Next, we want the perimeter of PSMR. The perimeter of PSMR. Right, the perimeter, let's look at PSMR. PSMR, the perimeter. So here you already know it's 5. Here you already know it's 5. This one, you already know there. Right, the equation. You know, this one is having the equation, that one. So the equation is -8. So which means that the coordinates of this point P would have -8, and this one here would have the equation as the equation PS, would have the equation y equals 3x over 4 plus 31 over 4. Y equals 3x over 4 plus 31 over 4. Okay. So that you just need to get the x if y is this. So let's do that one. So to find the perimeter here, we know that the point P has the coordinate -8 here, but that equation is this one. So we need to just to substitute everything. So y is 3 out of 4x plus 31 out of 4. Y is already -8, which is equal to 3x out of 4 plus 31 out of 4. Okay, you solve everything. 4 by 8 is -32. -32 minus 31, which is like -63. So this x is -21. X becomes -21. So you get this one is -21. -21. So if this one is -21, you think, because this one here is -6, the x is -6. X is -21. What is the distance between -6 and -21? So it's -6 minus into -21. And therefore is -6 plus 21. What is -6 plus 21? It's 15. 15. So PR is 15. So the perimeter, but this tangent must be equal to this tangent. So the perimeter of this shape, so we have that PR must be equal to PS, must be equal to 15. These are tangents from the same point. PR is equal to PS, must be equal to 15 tangents from the same point. So now here you'd come and say PR must be equal to PS, must be equal to 15 units. Because these are tangents from same point. Same point. What is MS? So MS is MR. MS is MR, which is 5 units. So the perimeter. Which is the perimeter is going to be PR plus PS plus MS plus MR. And what is PR? It's 15. What is PS? It's also 15. Okay. PR is the tangent is 15. Also, this tangent is 15. And then we get to this one, which is SM and MR, or RM and MS. Okay. And MS is 5. And this one is also 5. This is 30 plus. Okay, let me see. Okay. All right, that's fine, Mpo. Let me just look at that one. That's okay, Mpo. Mpo is saying, let's suggest how, let's explain how we got minus 21, because she gets a different answer. Let's just see. Okay. Let's discuss how we get minus 21 here. Right. We get minus 21 because we multiplied through by the LCD. So we have at this point, if you multiply through by 4, it's going to be minus 8 times 4. And then you multiply 3x over 4. You also multiply it by 4. You have 31 out of 4. You also multiply it by 4. Minus 32. You have 3x plus 31, which is 3x equals minus 63. You divide minus 63 by 3, which is minus 21. So that's how we get the minus 21. And the minus 21 becomes the coordinate of P. Okay. I know it's too many things I've written now. All right. Okay, that's fine. Thanks, Mpo. So multiplying just by the LCD. After I got that, want to find the perimeter. So perimeter means, what does perimeter mean? Perimeter of the PRMS. PRMS. How do you find the perimeter of PRMS? You add this one plus this one plus this one plus that one. You add this one plus this one plus this one plus that one. You add all of them. So if you add now, you have the perimeter here. So which means it is 15 plus 15, which is 30. 30 plus 10, which is 40. So the perimeter is 40, but we are adding distances, length of the sides, like the length of the tangent, the length of the radius. So the perimeter also is actually measured in units. It's measured in units. Okay, so we got the answer to that one. Next, last but not least for that question, we want to find the ratio. What is the ratio? The area of the triangle, this one, divided by the area of the quadrilateral, and we get the answer. Let's just do that one very quickly. So next we do the question, this one. Okay, I'm going to do a small division. I'm going to do it here. So we're going to do 4.4.2. How do you find the area here? So we say the area of triangle NPS, which is divided by the area of quadrilateral PSMR. Okay, I'm copying this question. And then what is the area of a triangle NPS? Let's look at the triangle NPS the examiner is talking about. Triangle NPS. Triangle NPS. NPS. Triangle NPS. The examiner did not close the triangle, but it's just referring to the points. And these points are 3 points, so they actually obviously span a triangle. They form a triangle. Okay. Now, what is this? What is the area of this? Okay, the area of this, we know already this one, the tangent. We said the length of the tangent is 15 units, like this one is 15 and this one is also 15. We got the 15 because we knew that this is minus 21 and this one is minus 6, and then we found the distance between minus 6 and minus 21, subtracting 6 and 21. Okay, the distance is positive, so you must subtract them so that you get a positive answer, So if someone asks you what's the distance between minus 21 and minus 6, subtract them so that you get a positive answer there. Okay, it doesn't matter how you subtract them, but the length, the distance cannot be negative. We got 15 units, the tangent here. If you have in mathematics a circle like this, and you have a tangent and a tangent here, these tangents are drawn from the same point outside the circle, so they must be equal. They must be equal. So now, so that in the end, what you're getting is okay. We're already done. This one, okay, we want to find the area of the triangle NPS. The area of a triangle is half base by height. The area of a triangle is half base by height. So if you close this triangle, you're going to have this one as the base. So if you look at the triangle here, you're going to have this one like this. This one is like a radius. This one is like a radius. It is perpendicular to the tangent. So the angle here is 90 degrees. So it's going to be like 90 degrees when you form the triangle like this. Okay, this one is already 15, but what is it? This one is 4. We found TS to be 1. So if you find the NPS, this one is 5, okay? So the triangle is like half base by height. The base is 15 and the height is 5. So we just need to find the area. So which means at this point, this one is going to be half base by height. Base by height divided by the area of the quad. The area of the quad. Okay, PSMR, PSMR, PSMR. What is the area of this quad? What kind of an area is this? Okay, also you can divide into two equal parts, but you can see that this is like a kite. Okay, this is like a kite because a kite has these sides that are equal and then you have short. Doesn't look nice. Okay, so you can have this. So a shape like this in mathematics is called a kite. So you can use the formula for the area of a kite, but you can split it into two. Okay, if you draw it like this, you split it into two, then you can find the area of the triangle, which is half the base, like this area. The base is 15, the height is 5. And then also here, you can find the area of this triangle. Half the base is 15, the height is 5. Okay, so you have those two things. So in here, you can actually consider half base by height plus half base by height. So the area of the top, half base, we said the base is the tangent, and the height we said is 5. Divided by here, half the base. We said the base is the tangent and the height is 5. Plus half the base is yeah. The base is 15 and the height is 5. So yeah, so you have the base is 15 and the height is 5. The base is 15 and the height is 5. So so what is this? It is half 15 by 5. Okay, you add these two. It's like half plus half, half of 15, 5. 15 by 5, 15 by 5, half of half. Half plus half is 15 by 5. And this is the same as what? This is the same as 1/2. This is the same as 1/2. So because there's 1/2 here. So this 15 cancels 15, 5 cancels 5, giving us 1/2. So which means the area they want. So they said find the ratio. So it means the ratio by the examiner. The examiner wanted the ratio. So it means that this ratio is just 1/2, just 1/2. Okay, for 2 marks. We found the perimeter for 5 marks and the perimeter worked out to 40 units. Right, next question. Okay, this video is being recorded, so yeah, not worry about copying anything. Everything is going to be available for you. Without using calculator, simplify the following expression to a single trigonometric ratio. So let's just simplify this over here. Okay, right. So you have the number 1. The sine is an odd function, so this the sine of minus theta is equal to the sine of theta. So this is like the sine of theta. So the cosine of 90 degrees plus theta. In each quadrant is that one is in the second quadrant. So in the second quadrant, cosine is negative. Negative, you divide everything by, right, theta minus 360. In which quadrant is theta minus 360? Right, theta minus 360 is actually in which quadrant? You need to think of that. Okay, so there are a couple of ways, obviously, of thinking of that one. But now if you imagine the angle theta is an acute angle, like 20 degrees, so 20 minus 360, it's going to be like minus 340. In which quadrant is minus 340? Right, the negative angles are measured from here, 0 degrees, minus 90 degrees, minus 180 degrees, minus 270 degrees. Okay, let me see what somebody's saying. In the third quadrant. Right, so it works out to pretty much that, okay? Okay, that's fine in Paul. I'm with you. Minus 360. Okay, yeah, okay, we're looking at it again in Paul. Because we're looking at minor ways, like first, for instance, for us to tell where theta minus 360 is, we must first tell where minus 360 is. Where is minus 360? First, we must measure minus 360. So the negative angles are measured in a clockwise direction. So 0, minus 90, minus 180, minus 270, minus 360. So if you measure, if you say 360 minus, take the theta to be very small, like 10 degrees, 10 degrees. So what is 10? What would 10 degrees minus 360 degrees become? It will become like a minus 350 degrees. So if you measure in mathematics, minus 350 is going to be like so, like here. Because this is minus 90, minus 180, minus 270, then minus 360. So after you passed minus 270, you would just say minus 350, then minus 360, like 10 degrees difference. And that puts it in the first quadrant in which all the functions remain positive. If they remain positive, then it becomes just positive cosine theta. Okay, I'm here to spend a bit of time on these, just revising the things. I know that obviously you can do this. So yeah. So this is actually the same as what? Okay, look, a small typo. There's a cofunction change at 90. Yeah, the 90 degrees plus is in the second quadrant, but there's a cofunction change. So this one, please changes, so it becomes minus sine theta. Becomes minus sine theta. 1 plus sine squared. All right, so it's going to be positive times negative, which is a big negative. So that becomes 1 minus sine squared. Theta divided by cosine theta. What is 1 minus sine squared in mathematics? Sine squared theta plus cosine squared theta is 1. Which means that cosine squared theta is 1 minus sine squared theta. What is 1 minus sine squared? Is cosine squared theta over cosine theta. What is cosine squared theta divided by cosine theta? It is actually cosine theta, and that is the answer. Next. Given that cosine 20 degrees is P, find cosine 200. Given that cosine 20 degrees is P, find cosine 200. First, you need to break it down to the 20. So you can say 200 is the same as 180 degrees plus 20. In which quadrant is 180 plus? Let's draw a small Cartesian plane. Right, so you have, okay, this is positive 180, so we're going to do positive angles, like 180 degrees, 270 degrees, 360 degrees. So you have the cost. So 180 plus, in which quadrant is that? So if you move 0, 90, 180. So if you say 180 plus, you're here. Because 180, you're increasing 180 like towards 270. 180 plus something goes to like 270, because 180 plus 90 is like 270. So it's like 180 plus is in this quadrant. So this one is quadrant 1. This is 2. This is 3. This is 4. So the quadrant numbers do not change, even if we go clockwise or anti-clockwise. 180 plus, therefore, is in the third quadrant, in which the 10 is positive and then the cosine is negative. The cosine is negative cosine 20 degrees. What is cosine 20? P. So this is minus P. What is the sine 70? So this goes out, which means it is minus the sine of 70 degrees. What is the sine of 70? Okay, what is 70 degrees in terms of 20? 70 degrees is the same as 90 degrees minus 20 degrees, because 90 minus 20 is what? Is 70. In which quadrant is 90 minus? 90 minus is in the first. This is 0, 90. So if 90 minus, you are making it smaller, you're going closer to 0. So 90 minus is in the first quadrant. In the first quadrant, where all these are positive, but there's a cofunction change to cosine of 20 degrees. What is cosine of 20 degrees? Cosine of 20 degrees is P, so that is minus P. All right. Um, so we continue. We continue. Okay, we continue. So yeah, try sine 10, please. Tell me what sine 10 is. Try sine 10. Sine 10, the next one. We continue. Anyone, please, sine 10. Okay. Anyone who is done, sine 10, 3 marks. Okay. Okay. Okay, anyone who is done, sine 10. Okay. Anyone? Okay. Is it too difficult? Or it's too easy? Sine 10. Okay. Okay. All right. Okay, let me see what somebody's saying. All right. Ayanda is saying it's done. All right. Thanks, Ayanda. Ayanda is saying it's done. Thanks, Ayanda. So, okay, that's fine. I'm going to do the corrections now. Senulo, what do you think? Senulo is quiet.
Uh,
Are you done?
yes, sir.
Okay, you're
Stuck
done,
here a bit.
right?
Yes, sir.
Okay, that's okay. It's not train smash. I mean, we are not fault hunting here. We are not here to punish anybody or to cause pain, but we are just here to um to make sure that you learn. Okay. 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 We continue. We continue. Okay. All right. Let's see. I was just giving a break. for a few minutes so that you can just enjoy yourselves. But now the sine 10, it's obvious. Because to get sine 10, we actually can use a lot of things. Right, but the most obvious of the things would be, because we already have a 20. If you have a 20 and a 10, the 20 is like a double angle. So when it's a double angle, you use the double angle formula. Okay, let me see what. Okay, that's fine. Paul is giving us twice P. It's awesome. Yeah. Okay, so you can look at that one is 90 minus 10. All right, and therefore it's cosine 10, and then it's 2P. That's fine. That's okay. I'm happy if you try. And then when you try, then when you do the corrections, then you can see what obviously this becomes. Okay, there are many ways to do this question, as a matter of fact. Right, there are many ways to do this question, but the most obvious would be if you have 10 and 20, the 20 is a double angle. The 20 is a double angle, so we continue. It then means that we can do this and say cosine 2 theta is the same as 1 minus 2 sine squared theta. So that if you have like the cosine of 20 degrees is the same as 2 into 10 degrees. 20 is the same as 2 times 10 degrees. Okay? And therefore, this is 1 minus 2, the sine squared of the 10 degrees. So, what is the meaning of these? We have just got, out of this here, we have just got cosine 20 degrees, which is equal to okay, so yeah, 1 minus 2,
Class for my daughter to
which is 10.
half past 6 this afternoon.
Okay, continue. Right, so you have cosine 20, which is 1 minus that. So the cosine 20, what is cosine 20? It's P, which is 1 minus 2 sine squared 10 degrees. So we continue. Continuing, then we have this one here. We need to solve for sine P out of this. So you can move the 2 sine squared 10 degrees, which equals 1 minus P. Sine 10 degrees, which is 1 minus P, you divide by 2. But it is squared. So when you have the sine squared, then you can take the square root on the left, which is sine squared 10 degrees, which is the square root on the right, which is 1 minus that over 2, which means the sine of 10, 1 minus P over 2. The sine 10 is the square root of that. So that is the answer. But so we continue. So now determine without the use of a calculator the value of this. So in other words, what is sine 10? Sine 10 can be seen as the square root of 1 minus P over 2. Okay, now there's another identity we use. Like if it's cosine, cosine, sine, sine, we know that we use the identity cosine alpha plus beta. That is normally at the back of the metric paper. Right, obviously we use the one with, I want to refer to the one with the minus. We use the cosine of alpha minus beta. So this is the same as cosine alpha, cosine beta. If it's minus here, it becomes a plus. Sine alpha, sine beta. My goodness. So this one here becomes the cosine of alpha and beta, which is a plus 55 degrees. A plus 55 degrees. We subtract. This is like alpha, then you subtract a plus 10 degrees. Okay, so this is like your alpha and this is like your beta. So if it's alpha and beta, you just minus the angles, you subtract them. Becomes alpha minus beta. Where alpha is the first one, a plus 55, and beta is the second one. Okay, this week, please, guys, if you're busy at night, during the day, we need at least 2 hours of your day to make mathematics more meaningful. Cosine. So we have a minus a becomes 0. 55 minus 10 is 45 degrees. So what is the cosine of 45 degrees? So the cosine of 45 degrees is the same as what? You can use your calculator. Let me see what somebody's saying here. Thank you so much, root 2 out of 2. Thanks, Lot and Paul. Root 2 out of 2. Root 2 out of 2. Right, so that is the answer. If you don't want to write root 2 out of 2, you can also write 1 over the square root of 2. Okay, they're the same thing. And obviously, they all come from the special triangle, which is the triangle for 45 degrees. So this triangle here, if you have 45 degrees here, I know, Ayanda, you might be seeing some of the things and wondering. So you are still growing. Do not give up. Do not think that this is like Greek. Okay. There's a triangle like this, which is called the isosceles triangle. It is isosceles because this side is equal to this side here, and 45, 45, and you have these. So the answer is the square root of 2 out of 2, or 1 over the square root of 2, and that is the answer. Next question. Next, they've given us this identity, and they're saying, consider this identity, prove the identity. Prove the identity. Let's write the proof of this. Let's write the proof of this. Now, to write the proof of this is pretty straightforward. How do you go about doing these? So you take one side of this. Like, going to take the left-hand side. The left-hand side is all this cosine 2x plus the sine of 2x, cosine squared. Divide everything. Sine x minus 2 cosine x. What is cosine 2x? Cosine 2x, we use the formula for that, which is cosine 2x is cosine squared x minus sine squared x, which is 2 sine x cosine x minus cosine squared x. So in the end, what does this give us? So it gives us the denominator can be written as it is, sine x minus 2 cosine x. Right. So cosine squared and cosine squared cancel out. Cosine squared minus cosine squared, they cancel out. And they leave us with minus sine squared. Minus sine squared x plus sine x cosine x. You divide everything by sine x minus 2 cosine x. And this now is, you have the sign, but that must be factorized out of this, which is exactly minus sine x. Okay, if you pull out minus sine x here, you are left with sine x here inside, but you also have minus 2 cosine x. Everything is divided by sine x minus 2 cosine x. Sine x minus 2 cosine x cancel out. Sine x minus 2 cosine x cancel out, and what we're getting is exactly minus sine x. Now the minus sine x is actually the right-hand side. For here, they said, consider this, prove that it is equal to this. And we have shown that the left can be simplified to the right. Next question is, you need to determine the value of these. Okay, now to find the value of these here, the top is cosine 2x, sine 2x, sine 2x minus cosine squared minus cosine squared. The bottom is sine x minus 2 cosine x. So, if you look at it very carefully, this you can simplify by writing the top. Cosine 2x, sine 2x minus cosine squared. Then you pull out minus 3 sine x. You pull out minus 3 sine x as a common factor. Here you're left with sine x. Here you're left with minus 2 cosine x. Okay. And if you look very carefully, cosine 2x, cosine 2x, sine 2x, sine 2x, minus x squared, minus cosine squared x, minus cosine squared x. The bottom is sine x minus 2 cosine x. So this is actually the same as these, but this whole thing, this and this is just minus sine. So we can proceed and say this with that together. So here you'd have 1 minus 1 over this. But this is minus sine x. So if you have the minus sign, then it cancels out and it gives us 1/3. Okay, so they said we need to determine the value of this. So the value of this is 1 over 3. The value of this is 1 over 3. All right, next question. Without using calculator, show that the sine of 4x is minus 0,5. So we're looking now at question 5.5.1. 5.5.1. So to do this question now, in particular to do question 4 or 5.5.1, we begin as follows. We focus on 310x or 310-4x. We focus on 310-4x, which is minus 2 cosine 4x, which is 3 into the sine of 4x divided by cosine 4x, which is minus 2 cosine 4x. Which is 3, the sine of 4x, which is minus 2 cosine squared of 4x. Which means you have 3, the sine of 4x plus 2 cosine 4x. So, which means you have 3, the sine of 4x plus 2 into the cosine, because you know that sine squared x plus cosine squared x is 1. Cosine squared x is, if you transpose the sine, cosine squared becomes the same as sine squared x, which means in the place of cosine squared, we have 1 minus sine squared x. And this equals 0. Three sine 4x plus 2 minus 2 sine squared x. Okay. You can just divide through by negative so that you have 2 sine squared x dividing by negative. This one is going to be positive. This one is going to become negative. Sine 4x. This one is going to be negative equals 0. So this one here is 0, which is, this is 4x. So that here you have 2 sine 4x. And this is the sine of 4x. Plus 1 minus 2. Which means the sine of 4x is equal to minus 1 over 2. Which means the sine of 4x equals 2. Okay, so obviously said show without using a calculator that the sine of 4x equals minus 0.5. So surely from this, we're able to see that the sine of 4x is minus 0.5, which is minus 1/2, which is minus 0.5. Okay. So this is the answer to the question 5.5.1. That is the answer. We divide the page like this. Then here on the side, we're going to do 5.5.2. Because hence determine the general solution of x in the equation, this one. This equation is basically the same now. The marks are just 3. So for us to find the solution, okay, this one is sin x this one is invalid, so it is not applicable. The reason is that the sine is a bounded function. It always is bounded between -1 and 1. So we're going to consider Sine 4x is minus half. Reference angle. To get the reference angle, we're going to do the arc sine of the positive ratio. If you do arc sine of 1/2, the result you're getting is 30 degrees. In which quadrants, in view of the cast rule, in which quadrants is the sine negative? The sine is negative in 2 quadrants. The sine is negative in the 3rd, but also the 4th quadrants. And because of that, we're going to consider both. 4x equals 4x equals. So what do we get out of these? What do we get out of these? Okay, we continue. Okay, in this quadrant, then you're going to have, this one is going to be like 180 plus 30 plus k times 360, which is 4x equal. What is 180 plus 30? 210 degrees plus k times 360. X is equal to 210 divided by 4 is 52.5 degrees. If you divide 360 by 4, you get 90 degrees. So that is the answer. Or you have another one. You also have 4x is equal to, so to get this one here, it's going to be in the 4th quadrant, which is 360 minus 30 plus 360 degrees times k, where k is in z. So this is 330 plus 360 times k. So which means x is, you divide by 4. What is 330 divided by 4? 330 divided by 4 is 82.5 degrees plus 90 degrees times k. K is an element of the integers. So we have that. Okay. So we are done. We have to find the general solution, determine the questions that determine the general solution of x in the equation, this one, and that is the general solution there. X equals to 82.5 degrees plus 90 degrees times k. The k is an integer. Obviously, or x equal to 52.5 degrees plus k times 90 degrees, where k is an element of the set of integers. Okay. Next question. Okay, obviously I'm watching the time as well. We started at about 10:30, just after that. So yeah, I'm watching the time. So we'll just be here for like 2 hours, and then we'll come back again at after 2. I'm gonna give you the time. I think that we're gonna come back 2:30, 2:30. But I'm gonna give you the time. Right, so we have question 6 in the diagram below. The graph of the tangent is this one. Then the equation, the defining equation is f of x equals the tangent of x minus 45 is drawn for x in that interval. Okay. Write down the period of f What is the period of f? What is the period of f?
November 2020. Like ivele they repeat amaphepha ango-2022 naka-2023 or like so.
Right, so the period of the tangent function, because now you just need to look at the fact that the coefficient of x is 1 here. And if the coefficient of x is 1 here, then it means that the period is 180 degrees. Is 180 degrees of the tangent function, in particular if the coefficient of x is 1. Next, draw the graph of the cosine minus cosine 2x for the interval minus 90 to 180, minus 90 to 180 still. On the grid given in the answer book, show all intercepts in the axis as well as the maximum and minimum points of the graph. Okay, I'm going to teach you how to use the Casio calculator to do this. But we need to draw the graph of g of x, so we're going to draw it straight here, minus cosine 2x. We want to draw the graph of g of x, which is minus cosine 2x. So to do that one, we proceed as follows. Let's start. Okay, so you need to just substitute the values. Like when x is minus 90 degrees, what is cosine you put here? 2 times minus 90 is minus 180. The cosine of minus 180 is 1, is minus 1. Cosine of minus 180 is minus 1. Right, so, but there is a minus there, making it a 1. 45, 2 times 45 is 90. The cosine of 90 is 0. So that becomes a graph. At 0 degrees, cosine 0 is 1 and then becomes minus. -45, 2 times 45 is 0. Well, 2 times 45 is 90. The cosine of 90 is 0. 90 degrees, 2 times 90 is 180. Cosine 180 is minus 1, but there's a minus, making it a 1. $135, 2 times 135 is like 270, cosine 270. Yeah, 2 times 135 is 270. Cosine 270 is 0. But there's a minus 0, just 0. So we continue. At 180, 2 times 180 is 360. The cosine becomes, negative cosine becomes minus 1. This is the graph. This is the graph. This is the graph. So we continue.
I'm asking ukuthi it's possible ukuthi ibefaka 2022 laka 2011 siphinde sibibhale ngo-2023 na.
Okay, we continue. Okay, we're to draw the graph. Now, the green graph I've just drawn is the graph of with the defining equation minus cosine 2x. And the other one is, it has the defining equation f of x equals the tangent of x minus 45 degrees. Okay, they said show all intercepts of the axis as well as the maximum minimum points. So there it is. So yeah, we have basically shown that, and this is enough. This is enough. Right, so write down the range of g. Here's the function g. The range now, it is from -1. You look at the smallest one, it is from -1 to 1. So which means that the range is y is an element of -1 to 1.
Oh, okay. Thank you, sir. Thank you so much. I'm waiting for Leslie because Wednesday I'm writing, so I'm waiting for her.
All right, so this is the range of the function g. If you don't want to write it like this, you write that y is
Yeah.
between -1 and 1. Okay, the graph of g is shifted 45 units to the left to form the graph of h, determine the equation of h in simplest form. Okay, so this is the graph of g. The graph of g of x is actually the same as minus cosine of 2x. The graph of x plus 45 degrees. Okay, it is shifted 45 degrees left. If it's 45 degrees to the left, you add 45 degrees to x because it's going to the left, so you add. And then this is the cosine here. 2 into the x becomes x plus 45 degrees, which is minus cosine of 2x plus 90 degrees, which is the same as the 90 plus is in which quadrant? 90 plus is actually in the second quadrant, in which the cosine is negative, but it changes to its cofunction, so it becomes sine 2x. Next question. Use the graph to determine the values of x in the interval between -90 and 90 degrees, for which the function f is strictly bigger than 1. Bigger than 1 strictly. Right. So let's look at this question here, 6.5.1. F is strictly bigger than 1. So if f is strictly bigger than 1, you're looking at this function. Where is it strictly bigger than 1? You'd agree with me that it's strictly bigger than 1 when the f function, which is the tangent function, is above 1. So it is actually, for instance, bigger than 1 from -90 degrees to 45 degrees. So when x is an element of the interval from -90 degrees to -45 degrees, -90 degrees to -45 degrees, the function is going up. Or where else? But obviously we are confining ourselves between -90 and 90. So we are looking at things from here to there. So it means, therefore, we are done because it's only here that this function is above 1. 1 is this one. 1 is exactly 3, so it's above, it's going up. But obviously it's also going up here, but the examiner said we must look at the graphs between -90 and 90. Between -90 and 90. So we don't go beyond 90. So this one is out of the area, is out of the region of examination. Right. So that is what we get. So we continue.
Okay, I think the answer is saying, but then format can be the same, but then question cannot be the same. So please research 2031. I don't know.
Okay. Next. We can write like this, that to say, obviously, from -90 to like -45, the function is the 10 function, the f function is going up, so it's above 1. But at minus 45, it's undefined. So we write open bracket like this. But at minus 90, it is at minus 90, it is equal to 1 exactly. So we are not looking at that part because we are looking at where it is actually bigger than 1. So we must consider minus 90 degrees less than x less than minus 45 degrees. So also now, if you look at this one, use the graph to determine the value of x for which this is the case. Okay, the examiner played a small trick here because we know that the function g is minus cosine 2x, but the examiner did this. So here at this pointer, you can perform a couple of things, which means we have 2 cosine 2x is bigger than 1, which means cosine 2x is bigger than 1/2. If you multiply both sides by negative so that you have cosine 2x, and then here you have minus 1/2, so it becomes less than 1. We're doing that because this is actually g. G is minus cosine 2x, so that it is effectively saying g is less than minus 1/2. So if it's less than that, g is less than minus 1/2. So it's less than minus 1/2. When is g? Okay, here is the graph. Where is minus 1/2? Minus 1/2 is it's like here. This is minus 0.5, which is minus 0.5. So if we're going less than that, you're saying we're less. When is that? So we are here. We are here and we are going less than that. So we're here. Less than that, we're here. Okay. But obviously we must confine ourselves between minus 90 and between minus 90 and 90. Between minus 90 and 90. Okay, between minus 90 and 90.
This question paper, yilo, no, yilo lizophuma na, or you're just guessing.
So which means that x here,
I'm not sure because that.
okay, so x here, it's actually therefore going to be minus 30 degrees to 30 degrees.
Yeah, so it should be.
Or minus 30 degrees is less than x less than 30 degrees. So ideally what we're saying here is that we have minus 30 degrees and we have 30 degrees. So this is what we have. So this is exactly what we get. Right, so when it's this true, you use the graph and you manipulate it like this, and you're able to see that when g is below, is less than minus 1/2, is when x is between those. Okay, x is between those. When x is between those. It's when x is between those. Okay. Let's just continue a little bit and finish off this question. Question 7. In the question 7, the diagram A, B, and C are points in the same horizontal plane. A, B, and C are on the ground, same horizontal plane. D is a point directly above C. D is directly above C. That is DC is perpendicular to AC, and DC is perpendicular to BC. It is given that ACB is 100 degrees. ACB is 100 degrees, and CAD CAD is 30 degrees. CAD 30 degrees. AD is 20 units. Right, AD is 20 units, and BC is 8 units. Right, calculate the length of AC. Calculate the length of AC. Right, here is A and here is C. We need the length of this. What is the length of this? That is obvious. So to find the length there, we're going to say in triangle ACD. Yeah, 1AC is like the adjacent over the hypotenuse, so we're going to use cosine. Cosine of 30 degrees is adjacent, which is AC, over hypotenuse 20. Which means AC is 20 cosine 30 degrees. Okay? And this is 20 cosine 30 is the square root of 3 out of 2. Divides 20 by 2, you get 10 the square root of 3. 10 the square root of 3, and this is length, and the length is in units. So they want AC, so clearly, therefore, AC, it's 10 the square root of 3 units. What about AB? AB. So you have this. What about AB? This one. Okay, so we have that AC is this one. It's 10 the square root of 3 units. That is the length of AC. And then we just need to find now the length of AB. Right, so to find the length of AB, we proceed as follows. How do we find the length of AB? The distance from here to there. Right, so obviously at this point, we need to use a couple of the methods so that we already know. Right, so to find AB, you already know this one is 8, this one is this, so we have the triangle. We can extract the triangle here like this. There's a triangle, there's a vertex B, there's vertex A, and there's vertex C. 10 into the square root of 3, it is 8 here. And this one is 100 degrees. And then we can use the cosine rule. This is exactly A, this is B, this is C, which means C squared is A squared plus B squared, minus twice AB cosine C. C squared is A, which is 8 squared, plus 10 the square root of 3 squared, minus 2A is 8, then it is 10 the square root of 3. Cosine C, which is 100 degrees. Use a calculator. This is 20,30. 20,30 units. So, okay. This is what we get, but now you need to take you get the answer, you take the square root. So that will give us actually the length there. The C, but this small c is AB. Okay, so if you use a calculator, you have a squared plus everything, cosine 100, you get the answer. And then now you take the square root of the answer, you get C, and C is 20,30 units. So that is the length of AB. We have just found the length of AB. We dealt with the triangle ACB. If it is further given that ABD is 73,4, ABD is 73,4 degrees. ABD is 73,4 degrees. Calculate the size of ADB. ADB. You need the size of this one here. So, right, so to do this one here, we just need to take this one. So you can just say the sine of ADB over AB. So first things first, we mentioned the triangle initial working in triangle. In which triangle? We're going to work in triangle ADB. ADB. So working in triangle ADB. And then we say the sine of ADB over AB. Okay, with the sine of ADB over AB, which is equal to the sine of ABD. The sine of ABD. The sine of ABD angle divided by, okay, if you look at the sine of ABD, you divide by ABD, you divide by AD. Okay, listen attentively because we're looking at this. This is called the sine rule, this. There's something we call the sine rule. What is the sine rule? The sine rule says sine A over A is equal to sine B over B is equal to sine C over C, where you have the triangle like this. And you have A, B, C, and this one is a small b opposite B, opposite angle A is small a, opposite angle C is small c. So this is the same as the sine of ADB divided by, what is AB? We've already got AB. Here I meant AB. Here I meant AB. We've already got AB, and AB, which is what the, obviously we got here, is actually 20,30. 20,30. Okay, then you have the sine of ADB. Okay. Rather, you have the sine of ABD here. ABD. ABD 73,4. Divided by AD. divided by AD. What is AD? AD is 20. AD is 20. So you put 20 here like this. And then you just need to get what they want, the ADB. Okay, so now to get ADB, it's this one here. Okay. Okay, that's a good question. Where do we take 20,30? Okay, that's fine, I under. 20,30 is coming from, is the length of 20,30 is from here, it is AB. So if you use a calculator and say, because we wanted to get AB and we used the cosine rule. Oh, all right, that's fine, that's awesome. Yeah, because if you use the cosine rule here and to get the actual C, which is AB, so we took this triangle that is the great triangle, and I drew the great triangle here. And then if you use the cosine rule, it is C squared is equal to A squared plus B squared minus 2AB cosine 100. Then you take the square root. Okay, if you take the square root of this is 20,30, which is AB, like that. Now, we want to solve for the ADB because they're saying find the size of ADB. ADB is this one. Need to solve for ADB. It's this one. What do? We cross multiply. Okay, I know that Tenulo is on the line. If we cross multiply these now, I don't just cross multiply and allow these to go there, because now if I cross multiply these, this one will go there, and it becomes 20,30. The sine of 73,4 degrees divided by 20. And therefore, if you have this, which is ADB, which is arc the sine of 20,30, the sine of 73,4 degrees divided by 20. ADB. Okay, you use now your calculator to get this one. ADB becomes the same as 76,58 degrees. 76,58 degrees. So that is the answer. That is the answer. So ADB is 76,58 degrees. And that is the answer. Right. We can't finish the whole paper, but I'm just going to have a feeling on geometry and then we're going to stop. Okay, I know that you guys are tired. Right, in the diagram, O is the center of the circle. In the diagram, O is the center of the circle. K, T, and L are points on the circle. And we have K, T, and that are drawn. Yes, hello, my dear. Please come again, my dear. All right, yeah. Okay, yeah, yeah, I didn't get the class, my dear. Okay, fine, thanks, my dear. Right, so you have that. So in other words, the diagram, O is the center of the circle, K, T, and L are points on the circle. K, T, and L are points on the circle, K, T, K, T, T, L, K, L, OK, and OT are drawn. OT intersects KL. So we have that OT intersects KL at M. ST is a tangent to the circle. ST is a tangent to the circle at T. STK is 36 degrees. And OKL is 18 degrees. OKL is 18 degrees. Determine, giving reasons, the size of the angle T2. What is the size of the angle T2? Where is T2? T2 is here. Who can find the size of the angle T2? Anyone? The size of the angle T2, anyone? T2 is here. What is the size of this one? Anyone? T2. Okay, it's easy because now you have a tangent, and this one here is a line drawn from the center to the circumference is called the radius. So a tangent is perpendicular to radius, so this angle is 90 degrees. So to find T2, you can just say, so T1 plus T2 is actually equal to 90 degrees. Right, you start by saying angle T1 plus T2 is 90 degrees. Tangent perpendicular to radius. What is T1? T1 is 36. Plus T2, which is equal to 90 degrees. Which means T2 is 54 degrees. So which means, therefore, which means you have 90 minus 36 degrees, which is 54 degrees. Then you have the angle L. So what is T2? So we have that T2 is 54 degrees. What is angle L? What is angle L? This one. Anyone? What is angle L? Right, angle L. Anyone? Okay, obviously angle L, it's easy because now if you look at a circle like this and there's a tangent like this, and you have this, an angle that sits here always equals an angle that sits here. An angle that sits here equals an angle that sits here. We say it is the tan chord theorem. So with that said, then the angle here must be equal to the angle between a tangent to a circle and a chord equals the one subtended by this chord, and this chord subtends this angle as circumference. So this here now, this chord here will subtend the same angle that is made by the tangent and the chord, and will subtend the angle of 36 degrees. So you have that. So L is actually equal to 36 degrees. The tan chord theorem. Okay, now they're saying for 2 marks, find angle KOT. KOT. Let's look at the diagram. KOT. KOT. Find angle KOT. Find this one. KOT. What is it? It's obvious.
Isn't 108, bro?
Please come again.
108.
Are you thinking that is 180?
No, 108.
108. Okay, that's a good question. 108. You are close because we're looking for KOT, right? K,
Yes,
O,
KOT.
this one.
Yes, we're looking for O.
Yes, we're looking for O.
So angular circumference is equals to 2 times angular center.
Yes. Okay, you are on point. You really are on point. Hello? All right. Okay, yeah, you are close. You are very close. You are on it, but yeah, there's something that you need to do a little bit. There's something that you need to do a little bit. Think about it again.
Okay, so
Okay, yeah, but you're on point. Just something small. Something so small.
so
How much? 32. Okay. Okay, yeah, sorry, I was speaking to somebody. Okay, yeah, you're on point there because there are two theorems we learn. There are three diagrams we learn. These three diagrams are all equivalent. So there's this one that goes like this. And there's another one that goes like, okay, you can take this point and you can move it like this. You can take if this one is it's a rubber band, and then you can stretch it like this, like a string. So this now produces an angle like this. So this diagram and this in mathematics are the same. But also you can move this one here and move this one here so that you have something like this. Okay, these diagrams are all the same in mathematics, but they all mean that angle at center is twice angle at circumference. Angle at center equals 2 times angle at circumference. So that now if you have AOB, C, the center is O, the center is O. Okay, if you move this one like this to the side and you have the C there, you have the A there, you have the B there. You would have moved the C there. Or you shift them around on the boundary so that this A goes up a little bit and the B goes up a little bit and the C is sitting there. So you'd still be having angle at center, which means that you'd be having angle AOB, angle at center, which is 2 times angle at circumference, like this. So we're going to use that. So if you use that here, you can see that this question the examiner asked, it is this shape, but it's turned upside down. So that, oh, it's this one, the A and the B and the C is like this. So you'll come here and then say KOT, which is the angle at center, is twice this one here. It is twice angle L. But you can see that angle L is already 36 degrees. And therefore, this is 72 degrees. Hello? Okay, I'm coming. Okay, so you have that kind of a situation there. Okay, sorry. Right, so we continue. We continue. So, we continue. Right. So what is the KOT? KOT is 72 degrees. Which means angle at center is equal to 2 times angle at circumference. So KOT is 72 degrees. So this angle here is twice this one, is 2 times 36. And 2 times 36 is 72 degrees. Okay, proof giving reasons that Km is equal to ML. Km is equals to ML. Proof giving reasons that Km is equals to ML. 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 Right, so this one is what we need to prove now. And to prove this, one way to prove that is to show that angle KMO, KMO is equal to 90 degrees. This one you already know that is 72 degrees. 72 plus 18. What is 72 plus 18? Is 90. So that this one is also 90 degrees. And if this is 90 degrees, it would actually therefore mean that you have a line, a perpendicular, this line here. It's a perpendicular, it will be perpendicular. So in mathematics, we then say that if you have a circle and you have a line from the center that is perpendicular to a chord, we say this means that this actually here bisects the chord. Like so. So when I say in triangle, KMO, in triangle KMO, what do we have in that triangle KMO? What do we have? We have that now we just need to find this angle here. So we need to find angle KMO, this angle. So this angle is going to be 180 minus this and that. 180 minus this and that. So it's 180 minus 18 and 72. So in other words, angle KMO is 180 minus 18 degrees minus 72 degrees, which is 90 degrees. Well, the fact that KMO is 90 degrees, the conclusion is therefore that Km is equals to ML. The conclusion is therefore that Km is equal to ML because there is a line from the center that is perpendicular to the chord. Then in mathematics, if there's a line from the center that is perpendicular to the chord, we say it must bisect the chord. It must be, if it's perpendicular, then it divides the chord into 2 equal parts so that M becomes the midpoint. And therefore, Km equals ML, which means we have the line from center, perpendicular to chord. line from center, which is the line from center perpendicular to chord, must bisect the chord. So we have that one. Okay. Right, we've had a little bit of the geometry, and I think that it's some good place for us to, let me see how much time we've taken. It has just been just above 2 hours here. So I will see you guys at 2. I will see you at 2. So at 2, I'll be looking at more mathematics. So yeah, see you at 2 p.m. It's just 11 past 1 now. So I will see you at 2. Okay. Okay, thank you guys. And see you at 2 p.m. I'm going to send the video link just now so that you can be able to understand this and play around with this. Yeah. But I'm going to be right back again on air at 2 p.m. So you can have water. And if you're energetic, you can come back at 2. And we're going to be looking at more things mathematics, more things paper 2. And yeah. All right. Thanks, guys. And goodbye to you. Goodbye, guys.
Thanks, sir.
Bye, guys. Goodbye, Ayanda.